35 million years ago, an asteroid roughly the size of a small city slammed into the bedrock of what is now Siberia. The impact was so violent, so sudden, that the graphite buried in those rocks was converted to diamond in a matter of seconds. Not slowly, the way diamonds typically form miles underground over billions of years, but instantly, explosively, and on a scale that no one fully understood until Soviet geologists stumbled across the evidence in the 1970s. What they found was what many geologists now consider the largest diamond deposit ever documented on Earth, and for decades they kept it completely classified. Today, you're going to find out why. 150 kilometers below the surface of the Earth, roughly the distance from New York City to Philadelphia, pressed straight down, lies the zone where natural diamonds are born. Under pressures nearly 50,000 times greater than the air we breathe, and temperatures exceeding 1,000 degrees Celsius, carbon atoms lock together into the hardest natural substance our planet produces. The process takes billions of years. The diamonds that miners pull from the ground today began forming before complex life even existed on Earth's surface. The only way those diamonds reach us is through a geological accident called a kimberlite pipe. Kimberlite is an ancient volcanic rock, formed deep in the mantle and forced violently upward through the crust at some point in the distant past. As it moved, it carried diamonds with it, like a slow-moving freight elevator rising from the deep earth. These vertical columns of kimberlite became the target of every major diamond prospecting operation in modern history. Find the pipe, find the diamonds. In practice, locating one beneath hundreds of meters of soil and rock requires years of survey work. Core drilling, soil chemistry, gravity readings, aerial magnetic surveys, and a great deal of patience. By the 1970s, geologists had mapped most of the world's known diamond-bearing regions. Southern Africa, Brazil, Canada, and Russia, particularly the Yakutia region of eastern Siberia, where the Mir mine, one of the largest open-pit diamond operations ever constructed, had been extracting gems since 1957. Yakutia was well-studied, well-mapped, and actively producing. What very few people were watching closely was a vast circular depression in the remote northern Siberian tundra, near a river called the Popigai. From above, the Popigai structure looks like a bowl pressed into the surface of the Earth. It spans 100 kilometers across, roughly the distance from downtown Los Angeles to San Bernardino, and it sits so low and so wide that it has its own distinct microclimate. Soviet geologists had catalogued it decades earlier. Most filed it as an ancient geological feature and moved on. What it actually was, and what was buried inside it, would rewrite the science of diamonds entirely. But before we get to what they found there's something important you need to understand about how a 100-kilometer hole gets carved into the surface of a continent. Most geologists studying Siberian diamonds think of Yakutia, the vast eastern territory where Russia's diamond industry was built, pipe by pipe, across decades of systematic prospecting. The Popigai River Valley, more than 1,000 kilometers to the northwest, was never part of those conversations. Nobody was looking there for diamonds. It wasn't on any active survey, and that oversight meant the largest raw diamond deposit on Earth had been sitting completely untouched for 35 million years. In 1970, a Soviet geologist named Leonid Masaitis, working at the All-Union Geological Research Institute in Leningrad, arrived at Popigai to investigate a different question entirely. He wasn't there for diamonds. He was trying to determine what the massive circular depression actually was. Previous expeditions had assumed volcanic origin, some kind of ancient caldera. Masaitis wasn't convinced. The rocks didn't look volcanic. They looked damaged. He found evidence of something called shocked quartz, grains of quartz deformed by pressures so extreme they can only be produced by one source, a direct asteroid impact. The confirmation changed everything. Popigai was not a volcano. It was one of the largest meteor craters ever identified on Earth, and while documenting the impact zone's geological layers, Masaitis and his team found something no one had anticipated. Scattered throughout the impact rock, locked inside layers of pulverized, fused, and cooled stone, were diamonds. Not a trace scatter. Diamonds distributed across the entire formation in concentrations that were difficult to fully comprehend at first. But that wasn't the strangest part. These diamonds were not like anything the Soviet diamond industry had ever pulled from a kimberlite pipe. What they were, and why they were fundamentally different, was a question that would take months of analysis to answer. And when that answer finally arrived, the Soviet government made a decision that kept it classified and undisclosed from the rest of the world for nearly 4 decades. The asteroid that struck Popigai approximately 35.7 million years ago, during the geological epoch known as the Eocene, is estimated to have been between 5 and 8 kilometers across. For perspective, the impact accredited with contributing to the mass extinction of non-avian dinosaurs roughly 66 million years ago was estimated at 10 to 15 kilometers. The Popigai object was smaller, but what it hit was what made the difference. Beneath that section of northern Siberia, the ancient basement rock, among the oldest geological material on the continent, held something rare in the deep rock record: large natural deposits of graphite. Graphite and diamond are made of the exact same raw material, pure carbon. The difference between them is entirely one of arrangement. In graphite, carbon atoms are stacked in loose flat sheets, which is why a pencil mark slides smoothly off the tip and onto a page. In diamond, those same atoms are locked into a rigid three-dimensional lattice, which is why diamond cuts through almost everything else. The asteroid did not care about that distinction. When it made contact, the pressure at the impact point surged to approximately 600,000 atmospheres, 600,000 times the air pressure standing around us right now. The temperature spiked above 2,000 degrees Celsius in a fraction of a second, and in that single catastrophic moment, the graphite in the surrounding rock didn't melt and didn't vaporize. It transformed. Carbon atoms rearranged themselves into diamond geometry before the shockwave had even finished moving outward through the crust. What Mercitus's team was pulling from the cooled wreckage of that ancient collision were the products of that transformation. Diamonds formed not over billions of years deep underground, but in seconds, by an impact so violent it left a crater the size of a mid-sized American city. The Soviet scientists called them impactites, and as the analysis continued, one fact stood out above everything else. These were unlike any diamonds Russia had ever encountered. Standard gem diamonds, the kind cut for rings, necklaces, and auction houses, grow as single crystals, one continuous lattice structure, which is partly what gives them their famous optical properties, the way they split and return light, the internal clarity, the fire that makes a well-cut stone appear to glow from the inside. The Popigai impact diamonds were different, because they formed under explosive, chaotic conditions rather than slow, deep earth growth. They crystallized as polycrystalline structures, meaning thousands of microscopic diamond crystals fused together at the molecular level during the instant of transformation. That structure made them, in certain measurable ways, harder than conventional gem diamonds, more resistant to grinding, more durable under industrial stress. For the gem market, they were worthless. For industry, for cutting tools, grinding wheels, precision instruments, and drilling equipment, they were potentially the most valuable industrial material on Earth. And that is precisely why the Soviet government, upon reviewing Mercitus's findings in the mid-1970s, marked the entire discovery classified. The reasoning was strategic. The Soviet Union's diamond industry in Yakutia was already a major source of hard currency. Selling gem diamonds through the global market was economically critical. Announcing a deposit of this scale, even industrial grade, risked destabilizing diamond prices and drawing unwanted international attention to Soviet geological capabilities. The decision was made quietly. The reports were sealed. Mercitus and his team were instructed not to publish. The Popigai diamond field disappeared from the public scientific record for nearly 40 years. What finally ended the silence was a deliberate choice. In September 2012, scientists at the Novosibirsk Institute of Geology and Mineralogy announced the deposit to the world. Nikolai Pokilenko, deputy director of the institute, stated publicly that the reserves at Popigai were sufficient to supply the entire global industrial diamond market for 3,000 years. Russian authorities confirmed the deposit had been known and classified since the Soviet era. The geological world took notice immediately. Here is what the Popigai crater actually contains. The diamond-bearing zone covers an area so large that geologists estimate the reserves at tens of trillions of carats. The entire current known global supply of diamonds, from every mine, in every country, across every deposit on Earth, has been estimated at somewhere between 1 and 2 billion carats in total, according to current industry surveys. Popigai alone may contain 35 times that figure. It is not close, it is not comparable. By sheer volume, it stands in a category entirely by itself. These are raw diamonds, uncut, unpolished, unprocessed, distributed through hundreds of meters of impact rock across a 100-kilometer crater in the Siberian wilderness. And yet, despite their scale and their industrial value, the deposit remains almost entirely unmined today. The reasons are practical. The location is remote beyond any existing infrastructure, the logistical cost of extraction is enormous, and Russia's existing diamond operations in Yakutia are already among the most productive in the world. There is no economic urgency to open Popigai, not yet, but the deposit is there, fully documented, confirmed by independent geological surveys, the largest concentration of raw diamonds ever recorded on the surface of this planet, sitting in a frozen impact crater in northern Siberia, formed in seconds by a collision that happened before humans, before primates, before anything recognizably related to us had yet appeared. The title promise of this video is now fully delivered. Geologists did discover the largest raw diamond deposit in the world. They just weren't allowed to tell anyone about it for 4 decades. The Popigai discovery does more than reset the record books. It reframes our understanding of where diamonds come from and what can create them. For most of human history, diamonds came from one source, the slow, deep work of the Earth's interior. Popigai proves they can also arrive from above, in a single catastrophic moment, in quantities that dwarf anything the mantle ever delivered. For the industrial cutting and drilling sectors, this deposit represents a future strategic reserve unlike anything currently mapped, and for the science of planetary geology, it confirms that impact craters are not just scars. They are, under the right conditions, vaults. 35 million years ago, a rock from space hit Siberia and created more diamonds in 1 second than the Earth's mantle had delivered to the surface in billions of years. Soviet scientists found them, confirmed them, and were ordered to stay silent. The world learned the truth in 2012, and today, that deposit, the largest of its kind ever documented, sits largely untouched in the northern tundra, waiting. What's worth sitting with is the idea that the biggest find in the history of gemology wasn't buried too deep or hidden by geological bad luck. It was sealed away by a filing cabinet and a government decision. The question that lingers isn't really about diamonds at all. It's about what else might already be known, already found, already classified, and simply not yet told to the rest of us. If you could make one decision about Popigai right now, mine it immediately and flood the industrial market, or leave it sealed and untouched as a future reserve, what would you choose? Drop your answer in the comments. It's a more complicated question than it first appears. If you found this story worth your time, a like helps this channel reach more people who love real discoveries told straight. Subscribe for more verified stories from the world beneath our feet, and we'll see you in the next one, because the Earth has not finished revealing what it's carrying, and some of what remains is remarkable.